Okay, so now begins our last unit. Surface area and volume of prisms and pyramids is what we're going to start with. This whole unit is about 3D figures, how to find the volume, the lateral area, and the surface area of a 3D figure. So basically this unit is going to be a bunch of formulas again. These formulas are given to you even on a SOL test for those of you that have to take it. These are not formulas that you have to memorize, but they are some formulas that you're going to have to know how to use. A few things that I want to point out: whenever you see a capital B, that's the area of the base. And the area is whatever that shape is. So you're also going to have to know the area formulas. Have no fear, those are also given to you on the geometry SOL sheet. Another important piece is this P, this little p. That's perimeter. And so that means basically you're adding up all the edges. So let's just point out a couple of things. The lateral area is the area of all the sides of the figure. It does not include the bases. It does not include the top and the bottom. However, the surface area is all of the sides. That includes the bases, the top and the bottom. And then volume is the measure of the amount of space that a figure encloses. A lot of the times when we think of volume, we think of how much something can hold, how much space it takes up. So let's just get started with doing some problems, and then as we go into that, I think you'll see how to work these things. So here's my shape. It's a rectangular prism, and then I matched up my formulas and shapes with this prism so I can find all the things that I need. So it looks like I'm going to need the length, the width, and the height. So the first thing the problem asks for is surface area. So if I look at my sketch over here on the left, I can see, comparing that to my figure, that my length will be 4, my width will be 5, and my height will be 8. Now it's not super important if maybe you got the width and the height or the width and the length confused, because if it was sitting on the more rectangular side, like if that were the base, then the numbers would change a little bit. It's not super important, but you just need to be consistent with them. So the surface area is 2, that's in the formula. The length is 4, the width is 5. We're going to add 2, length 4, height 8, plus 2, width 5, height 8. So all I did here is I looked at this formula and I plugged the values in. All right, there is nothing hard or difficult about that. All right, so, okay. We're just going to type those numbers in exactly like you wrote them. Plus 2, 4, and 8, plus 2, 5, and 8. We get 184. All right, so surface area means that it's going to be squared. It didn't give me actual measurements, like if this were inches or feet or yards or any of that, but it would be a squared number, rather like units squared is what it would be like. Not super important for this problem. Now, you might be asking yourself, where does the 2 come from? Why does this have a 2 in each one of them? Well, it has a 2 because we have a length and width, right? This is like the area at the bottom, and then here would be the area at the top. So that's why there's like that 2 there, because it's a top and a bottom, a front and a back, and then a left and a right. Why is that important? Because we have to find the lateral area. We don't have a formula for the lateral area for this rectangle. But I know if I take the surface area formula and subtract the top and the bottom, which would be this length times width and this length times width, if I subtract this, the surface area is going to be the sides and then the front and back. All right, so lateral area will just be 2LH plus 2WH. So length is 4. Now, the reason that I went ahead and did the lateral area is because it's going to save me a lot on my typing. I'm just erasing the first part, and I get 144. And now I got to do volume. So volume is length times width times height. So volume's going to be 4 times 5 times 8. So now 4 times 5 times 8 is 160. All right, next example. Find the lateral area of the rectangular pentagonal prism. So lateral area. Here's my lateral area. All right, so lateral area, I need the height times the perimeter. So I'm going to move this down just a little bit. So lateral area equals height times the perimeter. Ooh, how do I find the perimeter? Well, the perimeter is all the edges. So let's look at what we got here. So let's use some pink. So this is 9 inches. This is a regular pentagon. So that means all of these sides are 9 inches. And I have to add all of those together, along with all of these sides that are 9 inches. So how many of those do I have total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Carrie
So
Chafin,
I need
dial 5010. Carrie Chafin, dial 5010. Thank you.
Sorry guys, I'm making this recording at school. I've got 10. So the perimeter is going to be 10 of those 9s plus, let's go with green. This is 19 inches. So how many of those do I have? 1, 2, 3, 4, 5. All right. So 10 times my 9, that's all of the short ones, all of the short pieces, plus 5 of the longer pieces. Well, that's 185. So the perimeter is going to equal 185. Now I need the height. Well, what's the height? So let's see. If I look at my figure, this is a base and this is a base. And then it looks like the height is along the square or the rectangle piece. So looking at this, even though the base appears to be the rectangle, I can flip this, and this pentagon shape and this pentagon shape, that's actually the top and the bottom. Those are actually the bases. So that would mean that the 19 is the height. So then I need to say 19 times 185. That's going to be a big number. That's okay. We're going to get big numbers when we're working with volumes and lateral areas. So the lateral area would be 3,515 inches squared. So that's what it would be. Now, let's recap. Perimeter. Add all the edges. So add all the edges. All right. Height. That would be like the rectangular shape. Multiply those two, I get 3,515 inches squared. I'm going to get big numbers with these types of problems. Now I need to find the surface area and volume. So surface area is HP plus 2B. All right, the area of each base, this is an important piece. That means I didn't label what my things were over here. So P is 185, H is 19, the big B is 200. So do I have everything that I need to plug into my formula? I sure do. 19 times 185 plus 2 times 200. Now wait a minute. This is the lateral area, right? 19 times 185. So really, I could have just substituted this 3515 in. When I go over here to type this into Desmos, I've already got that part typed in. So now I'm just going to add the 2 times 200. And I get 3,915 for surface area. For volume is going to be the area of the base times the height. So my base is 200 and my height is 19. So 200 times 19 is 3,800. All right. Next one. And this is all this unit is. You label all the pieces that you have, you plug them into your formula. So I've got to find the lateral area, the surface area, and the volume of the following figure. So I need the base, which is the area. I need the height. I need the perimeter. And those are all the things that I see in my formulas. So the first thing I'm probably going to find is going to be this base. Now, I've got this formula. If I look at the base here, here's my base. All right. And I'm going to be using this formula over here. So let's see. My area is 1/2. Now, wait a minute. This is confusing because I've got a B here and an H here. Are my H's going to be the same? What do we think? When I do this triangle over here, I'm going to rewrite this. All right, that's a 4, that's a 3, and that's a 5. All right, the H and the area of the triangle could possibly be different than the H in the prism. This is just the base, okay? This H refers to the whole prism. So when I take this prism and I set it on this yellow base, my height will be 11 because it's going to go 11 centimeters up. So it's going to be an 11 there. However, when I'm looking at just the triangle base, the height, if I look there, this H is going to be 4. And this B is going to be 3. So the area, and this is where you guys are going to get confused because you're going to try to skip steps and you're not going to want to write stuff out and you're going to get it wrong. That's what's going to happen. So write all of these things down. And when I plug this in, my area is 6. What you have to remember is that this big A is the same thing as this big B. All right, it's 6. So now that I've found the area of the triangle, which is the area of the base, that's a 6. My height is 11. Now I've got to find the perimeter. So the perimeter is going to be adding all of these pieces up. So I've got 1, 2, 3 that are 11. All right. And what else do I have? Let's use orange. I've got 1, 2 that are 3. Pink. Now I've got this 4 on this 4. So I've got 2 that are 4, and then I've just got the little slant. We'll do purple. Now, that's a 5, and that's a 5. So I've got 2 that are 5. So my perimeter equals 33 plus 6 plus 8 plus 10. Now that's what I'm going to type in. Doing this a little bit old-fashioned and a little bit of just typing into Desmos. Plus 8 plus 10. It's 57. Okay. So now I've got all of the pieces that I need to use these formulas. So lateral area is H, which is 11, times the perimeter, which is 57. Surface area is going to be 11 times perimeter, plus 2 of my bases, which are 6. And then the volume will be my base, which is 6, times the height, which is 11. So 11 times 57, 627. Now I'm going to add 2, so 639, and now 6 times 11 is 66, okay? All right, last example. Very similar. Find the surface area, lateral area, and volume of the figure below if the slant height is 22. So slant height is 22. So see, this is where it's slanted. that's going to be 22. The height is 18. So the height is this here in the middle. So it's going to be in the middle of that, and it's going to come down, and that's going to be 18. And then each side of the base is 6. So this is 6. This is 6. All right. So now we need to figure out the big B, which is the area of the base. Let's make this a little bit smaller. The area of the base, well, it won't move. There we go. Area of the base is just going to be the two sides multiplied together, and that's just going to be 36. What do I need now? I need this H, which that's the height in the middle, and that's 18. I need this P. P is perimeter. So on this example, we're going to add all of these 6's together, and I'm going to change their color. So all of these 6's, and how many of these 6's do we have? We have 4. So, and then let's change the color again here. And we've got all these slants. I'm going to have to do some erasing so we can see how many slants, because there's this one in the back. So we've got 1, 2, 3, 4, and that was 22. And now, wait a minute, what about that height in the middle? Well, that height in the middle is just the height. It's like how long the pole would have to be inside of like the old-fashioned Indian tents. Do you know what I'm talking about? And there's not actually anything in that prism. So that H, that height, we don't actually include when we try to find the perimeter. So 4 times 6 plus 4 times 22 is 112. So now we've got perimeter is 112. And now what do we have? We've got this L. Wow, what is this L? Well, this L is like right there. Do I know what that L is? I'm trying to make it so you can see it. That L is right here. So what we have is, I'm going to erase this again. We have a length right here. This is 22, and then the whole thing is 6. I don't actually have that L. So what do I have to do? I need it. Any ideas? Well, I bet you're all thinking that right here there's a right angle. And whoa, wait just a minute. Right here in this red outline, kind of looks like I got a right triangle. Now, if I have a right triangle, oh, that's not a very good right triangle. There's right, this is 22, and this whole side is 6, okay? There was a rule that we learned that this distance L, if it was perpendicular, that these two sides would be broken into 2 equal parts. They would be bisected. And so now, if I take this away, I have a right triangle. And guess what? You got it. Pythagorean theorem. Oh, Miss Bearden, when are we ever going to get to stop using the Pythagorean theorem? Never. Never, ever, ever are you going to stop using the Pythagorean theorem. He will be your best friend in life. You might be in a traffic jam one day, and you might be able to look around and realize that the best way to get out of that traffic jam is if you could use the Pythagorean theorem. I'm telling you, it's going to happen. So, X, or rather L, is 21.794. Now that's not a very pretty number, but we're going to use it. 21.794. 21.794. So, what are we doing? We've done a lot of stuff. Look how much work we've done, and we haven't even answered the problem. Yeah, that's why you guys get tired of doing these problems and you start to make mistakes. So, just take your time, go easy, it'll all work out. So, volume is 1/3 of the base times the height. The lateral area is 1/2 of the L times the perimeter. And then surface area is 1/2 perimeter plus 36. Okay. I'm going to erase some of this just so that we can see it. Actually, I need to put that back though. I want to move it over. Move over. Alright. So now, pull out the handy dandy calculator. Oh, come on. I'm going to type in 1/3. 36. 18. 216. Now, I'm going to type in 1/2. That 21.794. Oh. And the 112. And I'm going to get 156. And I'm just going to round this one and say 156.5. And then the last one, I'm going to add the 36 to it. And I get 192.5. Whew, that last one was a lot of work. So, to recap, find all of the little pieces that you need in your formula, and then you just plug those pieces into the formula.